Okay, so time here is 6:37. Got up at 4:15. Woke up a little bit. I ate my breakfast. Had 1 cup of coffee. I'm trying to cut back. So I'm going to do some work on my personal amp today. I've done enough amp work this week. A lot of hard box sales, so I need to take a little break. Next amp up will be a 922. I have another one that had a bad filament transformer and a bad band switch. So a customer decided to just give it to me. Well, I waived the bench fee and said I could have it. So I'm going to end up at some point going through that. But so that one's up for sale. When I have a buyer, I will fix it, do all the mods to it. Replace the filament transformer with a stock one, get a brand new multi-tech band switch, and brand new set of tubes. So, alright, so what I'm doing today is 2 of these caps. I forget which ones, I have to look at all of them. But 2 have a pretty good dent in the side, so I'm not going to take a chance on that. So my buddy Jim Ve7rf sent me, I think 3. They're in the box. So I'm going to replace those 2. Then I'm going to put a diode across each capacitor and a 100K resistor across each capacitor. And then use Teflon wire to jump each capacitor. And then next step will be stripping the rest out of this, what's not going to be used, and the filament transformer, and we get some of the stuff mounted in there before I drop this in the cabinet. So to secure that, this fits right in, and if you want to see how that looked, you can look at one of my other videos on it. And look, I've been publishing videos from the beginning till I'll have one till the end showing it in operation, just like I did with a 6-meter amplifier. So I'm going to drill a hole, and it'll just have it's got some weight to it, so I'm just going to have one screw holding it down. I might put a dab of silicone around each edge, but I want this to be able to come out, if I have to take it out. So, but you notice that each capacitor is isolated from each other, and then they're also isolated from ground, which is the chassis. And I used plastic clamps or nylon, whatever they are, so the brackets wouldn't have to be isolated, because they could, you have the can underneath this blue stuff, this material, plastic, it's metal, so that's the negative side of the cap, and you wouldn't want that right up against bracket. I just don't want anything arcing or any issues, so probably a little bit overkill, but I like doing things right. There's so many things out there that just are not done right. Just because something's working doesn't mean it's going to continue to work, or it's working at its maximum potential or efficiency. Okay, so this is where the blower is going to sit. The blower is going to hang from the cover for this compartment, and it'll push air through the bottom of the RF deck compartment. So the hardest part of this whole project was the RF deck, and that is done other than adding the output safety choke. I just have to wind one up real quick, and then that'll be good. But this is going to be cool, and again, when it's done, this isn't really a moneymaker making amplifiers. It's more for the fun of it. And when this is done, when people see it working, I will, if someone wants to buy one, price is going to be up there, but I might do one a year, one every couple years, as time permits. But I can just copy this one from that point. I'll just, same design, I'll, obviously put it in a new cabinet and new parts and all that. But, so, most likely would be 80 through 10. I don't think anyone wants 160, so I can add one of the work bands or whatever, you know, whatever the customer wants. So, but again, with a progressively shorting rotary switch. A lot of people use a roller inductor. It's super, super easy, but that is really not the optimal way to do it. Especially something like this with this size tube, because you know, you need a 30 amp inductor and it's huge, and you run into issues with such a large inductor. So, but if I do this again, it's just the 6000, nothing 3CX6000. That's it. That's the only thing I'm going to do. That's it, period. I've made larger stuff in the past, but it's just not worth it. It's crazy how much money parts are nowadays. I don't know if people have been keeping track, but things are very expensive, and the price is only going to go up. Up, up, up. Okay, so, and again, this one is not for sale. This is my, I'm like pushing, I have to push myself to do this, because I'm working on amps all day. I work on at least 1 amp per day. Could be waiting on a part like a SB1000, waiting on a Ve7rf for that. That's all done. I already tested in all bands, but that should be here today. But, you know, so if I'm waiting on a part and I don't make a video until it's all set, you know, so, but sometimes I don't even bother making a video depending on what it is. But very, very busy here, never ends. Okay, so that's enough yapping away. Got the parts from DigiKey. I'm going to get to work. I'll see you guys soon. Stay tuned. I want to explain something real quick. So these are 100K. I think they're 3 watt resistors. Yeah, 1%ers. These capacitors are a lot of money new. I think Jim said they're like 150 bucks each. Normally I use oil caps, but I can't fit them in this cabinet. The 6 meter amp, I only had one of those 4kV 60 microfarad caps left. I put 2 in series in that amp, so I ended up with 30 microfarads at 8 kV. This is going to have, it would be really close to that. It's going to be around, I forget what it was going to be, but it would be really close. So I don't want to, plus I don't have another one, so Jim said, why don't you just do this? I was like, okay, well, I'll give it a shot. I've never used electrolytics like this before. So, okay, so people are going to be like, why are you putting diodes across the caps? So the reason why I'm doing that is, if I ever had, well, this is using a full wave bridge, so if I ever had a string of diodes, the bridge short, I wouldn't want to pump raw AC into the capacitors. This will also have a high voltage fuse. It's going to have a series glitch resistor, but the glitch resistors, you know, on the positive side, that wouldn't help the caps when it comes to a diode string shorting. You know, so anyway, I want to protect these capacitors, you know, so if that happened, the diodes would short, and then they protect the capacitors. So this is a lot of money's worth of capacitors, like 150 times 20. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, 20. Okay, so I'm going to get to work. A lot of wire wrapping and soldering, and you know, so I'm going to put my music on. I don't do crazy long videos. Those are boring. You know, I like to keep them nice and short. People end up fast forwarding through it anyway, and then they end up missing stuff, you know, if it's a crazy long video. But I just like to give the important info, and there it is. See, here's one of them. It's the ding. See, it's like pushed in. Probably be okay. I'm going to save it. I won't throw it out, but it's just not worth it. You know, I don't want it would be bad. So, okay, so I'm going to get to work. I'm going to crank my music up, and I'll be back. Wish me luck. Please like, share, and subscribe. Okay, so I'm back. I got everything all wired, and I have a special guest on the phone. He'd be happy to come down here, be in person, but he's kind of far away. And so, without without further ado, here is Mr. Jim, Ve7rf. How you doing? It's early up there. What time is it up there?
It's 10 to 7 on the Pacific time here on the West Coast, so pitch black outside.
Yeah, where are you located, Jim?
I'm in Victoria, BC. I'm on the southern tip of Vancouver Island in the capital city of British Columbia here.
Hey, Jim, how long have we known each other so far? Like, how long's it been?
I'm just trying to get, I don't know, this must go back, what, 6-8 years or something like that?
I would say over 10 years. Well, yeah, I met you before I bought the first house, so over 10 years now. Yeah, over 10 years, easy.
Okay, I stand corrected. Senior moment. Okay, here we go.
How many amplifiers have we helped each other with and come up with new original ideas? And how many do you think?
I'm just trying to guess. You're somewhere between 8 and 14 or something.
Yeah, more than that. But okay, so I put you on video before. You saw the capacitors and all that, and you hooked me up with these caps, and I appreciate that very much. And whenever you want some parts, I always return the favor. Yeah, I showed you this neat crimp idea. So what I did here was I took, let me just show this real quick. I took one of these things and I cut the barrel crimp, stake on, and I cut the barrel piece off, the crimp part, and then I stuffed the silver-plated stranded Teflon dielectric wire, and I slipped it over the pin, as you can see here, coming out of the capacitor. I'm sorry, say it again?
16 gauge silver stranded.
Yeah, 16 gauge silver.
Teflon coated.
Yep, and then 100K resistor, 1%, and a 6 amp 1 kV diode all within one, crimped it, soldered each one. Then you got the nylon clamp, so you want them isolated from each other and from the chassis. It's got a 3/4 ply piece of wood, screws only going a little bit. You know, if I had access to my machine shop guy, I thought about having a thicker piece of material and have them bore out a hole, drop each one in, but this is my own personal amp, and yeah, I didn't want to go too crazy, so fortunately I lost that connection with that guy. He retired, so, but I think it came out pretty nice. So okay, so I'm going to let Jim explain some stuff here, and I got some glitch resistors here and a high voltage fuse, and he's going to give all the technical specs on all this stuff and why we picked everything for this amp and how we don't just copy something, and why everything has to be engineered and carefully calculated, and you know, everything properly laid out. You know, so there's a lot to this. So sorry, Jim, I'll let you go ahead. So
okay,
go for it.
Those capacitors, electrolytics, with the 3 pins on there, they're originally designed like an isosceles triangle. The 3rd pin is unused. You can see that in the video. They're originally designed for circuit boards. And the reason they did it, the triangular thing, is it gives it a bit more support because they're 4-inch long, 2-inch diameter. They got, you know, a tiny bit of weight to them. In this case, we're plus with the 3rd pin, the original idea is when they're inserted in a circuit board, they could only go in one way. There's no way you could flip them 180 and have the polarity reverse. So, but that's water under the bridge. We've got them inverted and with a nylon clamp at the base, so they have to be hardwired from one to the next.
And that was a nifty idea, right? That was a cool idea I came up with.
I thought that was slick, putting that stake line, blopping the end off and crimping that worked out good, rather than trying to wrap 16 gauge solid wire from the diode and you know, plus the resistor, plus the 16 gauge stranded. That's it. So these are crimped, soldered, bulletproof.
The nylon clamps.
Capacitors, yeah, they're 95 centigrade caps. They're 9.8 amp ripple current rating. When I run it through software, when you're pulling 2.5 amp DC plate current continuous. The AC ripple current going into the caps is 4.6 amps. It's 80% more than the DC plate current. You know, on an oil cap, it's not that big of an issue, but electrolytics all got ripple current ratings you got to keep under, so we're only running them at under half of what they're rated at for ripple current, so that solves that problem. Okay, correct me on the transformers here. There's two transformers in parallel. They're both 5,300 volt secondaries.
AC, yeah.
Yeah, what were they, 125 pounds each or something?
I forget. I think they might have been 140 pounds each. I'd have to go. I have a picture of one on my website.
You weighed one of them, and they were 19 ohm secondaries. We got two in parallels. We only got a 8.5 ohm secondary.
Yeah, they're made by the company. They're used. They're Magnaspec, same company that made the ECA brand for Henry Radio, and also the guy, I'm not going to say his name, but the guy in California that made high power amps. They're really they're wound very well. They have very little sag under any, from no load to any load.
Okay, so when I run this through software with a 2.5 amp continuous load, we end up with the peak-to-peak ripple voltage ends up to about 125 volts. The RMS value is only 44 volts. The ripple is only 0.6%, 0.6%. To put that in some kind of perspective, that works out to minus 43 dB of ripple reduction at 120 hertz, and then at multiples of 120 hertz, it's down and down and down. It's even further down. To put it into perspective, what you get on like a Drake L4B with 8 electrolytics in series, that works out to about 2.9% ripple, and it's about minus 30 dB. This is 0.6%, and it's minus 43. This is like right to the floor. So that's a non-issue.
Yeah, you forgot to add that the plate supply is actually 3 amps continuous. So we're on.
Each transformer is an amp and a half on the secondary continuous. They're good for 3 amps at 5,300 volts. That's basically 16 kVA worth of transformers in there. So that's not going anywhere. After the full wave bridge, and I forget what you proposed to put in there. The standard bridge was what, 6 amp diodes in there, or 10 amp diodes in there.
Yeah, I'm not sure if I'm going to use. So I have like a whole bunch of options out of broadcast transmitters. I don't know if I'll use.
That's neither here nor there. That's just semantics. We put a between the parallel secondaries and the input to the bridge in one leg only is going a bus high voltage fuse.
So I'm showing one of them here now. And it's sand filled, right?
Yeah. That's 5 kV ratings, the AC rating. We've had them up to 8,200 volts DC through. Those things are flawless. They're 5-inch long. I don't know if you got any of the silver-plated end retainer clips to show in there or not.
No, they're around here somewhere. I do have them here, but yeah.
They snap into a silver-plated clip that goes on standoffs. They're a unique kind of clip because they got end retainers, so whether it's not horizontal or vertical, once it's in, it cannot slide out of the fuse holders. They're 100% locked in. Okay, and then we put a second high voltage fuse on the B plus output coming out of that bank of capacitors to 20 electrolytics. It's a second identical HVU3, and then it goes into the 50 ohm glitch assembly, which consists of 4 glow bar. What are they, type SP?
Yeah, 50 ohm.
Yeah, they're inch diameter, 12-inch long.
So I'll have two in parallel in series with another two that are in parallel.
So we end up with 25 ohms in series of 25 ohms. We end up with
50.
back to 50 ohms. And the idea here is the glitch assembly is, say you had a anode to grid short arc in the tube or B plus to chassis somewhere. The 50 ohm glitch assembly limits the current, the fault current, to something safe, to a safe value.
And the glitch assembly will survive, but the fuse will open up. It'll allow the fuse to open up real quick.
It's basically like 7,500 volts divided by 50 ohm glitch. Your fault current's 150 amps. Well, the 150 amp of fault current will open up a 3 amp rated fuse in less than 2 milliseconds. We've measured all this, so that this is old news.
Yeah, I'm showing one of these 18-inch ones also. See, I have like over 100 of these, like just a couple. I mean this. I've used these larger ones in configurations depending on the amount of current the plate supply poles will determine how many. But I've used 4 of these. These are 200 ohm and wanting up to give me 50, but it's overkill for this. But luckily, I have a whole bunch of these. These are becoming more and more expensive, and they're the optimal resistor, right, Jim, for this application?
Oh, yeah. Yeah, they make one slightly better one that I use, are type AS, which are made for glitch service. They won't handle as much, they don't have as much wattage, but they'll handle higher energy content. But that's, now we're cutting fine hairs here. We got to go with what we have. So that solves that problem. That's if you're on the outboard side from the capacitors towards the RF deck. If there's any kind of problem with the electrolytics or anything inboard, that 3 amp fuse and the glitch.
Oh, I lost him. Gotta call him back. Hold up. I wonder if his phone went dead.
Hi,
Hold on. Take a pause here. Okay, I got Jim back on the phone. Go.
Yeah, we had a minor technical glitch there.
Right, so you're talking about now the fuse in series with the glitch resistors.
Yeah. Okay, so with 7,500 volts and we take that, we square it, we multiply it by the 125 microfarad, divide that by 2 million, and we end up with 3,500 joules of energy stored up in those caps. That's joules a watt second. So if you want to put that in perspective, you only got 87 joules stored up in a L4B at 2,600 volts at 25 microfarads. Here we got like enormous amount. Basically, the premise is if you want to run 10 times as much DC input, you need 10 times as many joules in there. So we need at least somewhere between 900 and 1,000. We got 3,500, so we got ample there. Okay, if we have a problem inboard of that HV fuse and glitch assembly, that fuse isn't going to do us any good. So we got a second high voltage fuse in there between one secondary leg. It only needs to go in one leg. Pick one, doesn't matter, between there and the full wave bridge rectifier assembly. So if something happens there and we get a B plus to chassis arc or something goes haywire, or the interconnects or something like that, then it'll take out the second fuse.
Did you already talk about the one in series with the B positive? I forgot.
Yeah.
Oh, okay,
Yeah,
so I had it
we
backwards. Oh, I had it backwards.
Yeah, so we're
it's
doing
still early here, and I get up at 4:15. What's it like?
Yeah.
Oh no, it's not too early. It's only 10. It's 10 o'clock now.
Yeah, you're 3 hours ahead of me here, so.
I haven't had more coffee yet, so.
Anyway, so the idea is that second fuse between the secondary, the high voltage transformer parallel outputs, and the full wave bridge rectifier will open up ASAP.
Yeah, and
that'll save your diode bridge from going up like it'll save it. It'll open up faster than say 100 amp two-pole breaker in the 240 mains line.
Can I add something here? These diodes across each cap, a lot of people probably aren't used to seeing those. Those are in case a diode string were to short, in case raw AC were to hit the capacitors, it'll protect them.
Yeah, if it's an oil cap, is one thing. If you have one leg of the 4 legs of the full wave bridge rectifier failed, shorted, what you'd end up with is a condition where you'd be pumping raw AC into the string of electrolytics on half cycles, and that would fry the cap. So the idea of putting those reverse connected diodes across each electrolytic is, in the extreme rare event that ever happened, the diodes would all of a sudden conduct, and that would take out the high voltage fuse number 2 between the secondary, the transformer, and the diode board. So
because these caps are not cheap.
They are very, very stupid expensive. They're like over 100. If you're buying them in onesies and twosies, I priced them out years ago, and they were like $107 each.
Yeah, didn't you say they're up to like 150 or something now?
No, I forget. They were over $100 each. So.
And then how long should these should last my lifetime, right? Because they're, first off, they're getting blasted with air. They're nowhere near their temperature rating, and they're nowhere near their max ripple current rating, right? So
yeah. This is okay. Just to clarify something else here. When they say that 95 centigrade rating they got on there, that's the ambient air temperature that's surrounding the outside casing of the cap. You're not going to have anywhere near that. You're going to have, basically, you can explain how the blower assembly is going to work, but it's going to be room air getting sucked in past the caps. You'll never get more than, say,
80 or so.
80 degrees.
Yeah.
You're talking maybe 26 centigrade, and you're nowhere near 95.
Yeah,
that's a non-issue.
So something else we should, a lot of people don't know that caps usually have an hour rating, and that hour rating is based off of, they go by the max temp. So if you're at the max temp, you got the temp maxed out, and you got the ripple current rating maxed out. So
we're not running anywhere near that.
Yeah.
When you do all the math, and it ends up the cap's good for freaking tens of thousands of hours.
So another thing we didn't mention is, well, I think I did in other videos, but this amplifier is going to have an opto isolator controlled grid and plate overload circuit. So that'll be another thing that'll shut down the primary of the plate transformer if there's ever a some sort of issue going on.
Yeah, here's one issue with any grounded grid amp. If you got this fuse /glitch assembly in the B plus line, if the fuse ever opened up and you lost the B plus,
you peg the grid current,
and you apply any amount of drive, you'll peg the grid meter, because the tube now thinks the control grid is the anode instead of being the grid. And I've done this before with back in the day of 1000 amps, you kill the B plus and put 10 watts of drive into it, and peg the grid meter. So we don't want to do that. So Scott's got a high-speed grid overload in there.
Grid and plate, so that I can feel comfortable, because like yourself, who wants a noisy amp near them? It's going to be in another room, and it'll be run obviously within the legal limit and just headroom. And you know, you need the right, I mean, you need something like this. I mean, there's so many people do FT8 and they talk on AM down on 75 meters, or they do contesting. Something like this will allow heavy use, you know, and no meltdowns. But by having it in another room when you're not near it, the peace of mind knowing that if something goes crazy, it'll shut down. Not just the grid and plate overload, but a thermal sensor. You know, if it gets too hot or if the blower shut off, the blower if that died or something, it has a interlock switch, a pressure interlock switch. So all sorts of things to protect it, you know, so you don't do more damage and just totally kill the amplifier. Just these small things really help out a lot, you know, from costing yourself a lot more money if something small happen. You know, like if the blower quit, you know, you can end up killing the tube and all sorts of other stuff. So it's good to incorporate these things in the design.
Yeah, you're talking expensive too. Parts are they're expensive, so you got to protect tube from lack of airflow or whatever. I don't know if you talked about the filament setup. How are you going to do the filament? We're going to have Variac on the.
Oh yeah, it's basically the same as the 6 meter amp. I'm not sure if I'll do a soft start yet or not. I mean, the transformer's wound to limit the amount of inrush, but yeah, so not sure with that. I was going to say something else, but yeah.
I would probably give it some serious consideration because they're supposed to limit the inrush to no more than doubles, but what were you going to do? Parallel 250 amp transformers?
No, I actually have one single transformer. I have a 6000 transformer out of a broadcast PA.
Yeah, it's like 80 amps, so limited to 160 amps, so it should be all right.
Well, remember, it's going through the Variac also. It's a panel mount Variac, so that'll actually limit it a little bit also. There'll be voltage drop through that when it pulls a bunch of current to start up. But
so the idea is run the filament if it's a brand new tube or rebuilt, run it at rated voltage measured right at the cathode, and run it at 7.0 volts for the first 200 hours, and at that point we can back the filament voltage down 5 or 10%, because we did it before. We backed it down to 6.3 volts and another 3x6 amp I designed for a fellow that's still functioning, and it's still sitting at 6.3 volts, and it's got like 6,000 to 8,000 hours. That one's got an hour meter on the primary filament setup, so we know exactly how many he had. He knew exactly how many hours he had on it. That was just an add-on thing, and anyway, so we keep track of it. So
there was something else that
we talking about the RF deck now, or
no, like we're gonna wrap this up soon. But there was one other thing I wanted to we're gonna do more of these as we go along. I don't want to pack too much into this and be like other people that do like 2-hour videos. But what I was gonna say is, as you know, I've done a few grid-driven tetrodes in the past, but there have been people who have said, I'm not going to mention names, why didn't you build a tetrode? Why don't you explain why we just used the 6000 tube? One of the reasons I have two brand new ones here, but why, and all the other parts, but most of the parts. So why don't you touch base on why we went that route?
The 6000 and the 3000, aside from both, they got a 50 ohm input impedance. They got a big grid in them. They're 225 watts, and that's if they're grid driven. In this case, grid's bonded to the chassis, which is ice cold. The grid dissipation is technically a little higher than that.
Wait. You talked about 3000 and 6000 being grid driven. Did you mean another?
No. Yeah, if they were grid driven, those grids are rated for 225 watts.
Okay.
In this case, we're cathode driving the thing. Grid's bonded to the chassis by the grid ring chassis is ice cold because it's got a ton of air through it. We got 50% more air than what IMAX specs. We got, instead of 204 CFM at 0.4 of an inch, we got 330 at, I think it was 0.9 of an inch. So we got 50% more airflow. Anode dissipation went up 20%. It's up to 7,200 watts continuous, and that's if it was 104 Fahrenheit in the room, which it's not. So you factor that in, knock it down to 75, 80 degrees. Anode dissipation is just a hair under 8,000. So because this 3x6 tube is an easy tube to cool because it's got a huge, massive under fin area compared to the center stem. So the problem with using a tetrode is like a 4CX5000 or a 10,000, they've only got a real small grid in there. They only got a 75 watt grid and 250 watt on the screen. Well, when you bond the screen and grid together, the control grid gets hammered first.
Oh yeah, that's if you're cathode driving it, but I'm talking about if we did a grid driven amp. But yeah, a lot of the guys do that and they don't understand that now they're limited to the control grid total wattage rating, and they end up, it requires more
like
drive.
Even on a 4CX15000, for example, that's only got a 200 watt grid, whereas if you took the triode version, like a 3CX10000, 15000, 20000, they all have a 500 watt grid. It's designed for the job, right? The problem with, I mean, this is basically simple. We're looking at maybe, you know, if you want to drive this thing to 10,000 out, you need 500 watts of drive. So, you know, basically you need a small IPA. If you're going grid driven, okay, we need a regulated screen supply, you know, to bias supply, you know, one voltage to cut it off and another bias voltage for normal idle. It may or may not have to neutralize it. You just complicate it a lot more for the small advantage of being able to use like far less drive power. The IMD on this thing is absolutely superb. I mean, it is outstanding at 10, 12,000 watts peak envelope power output on
if you don't have a stable screen, if your control grid and control grid and screen grid voltage, if you have voltage on both grids, if it's not rock solid, then your IMDs will be all over the place if it's fluctuating.
Well, then you got other issues in there, like if you had an anode to screen arc, you're going to have issues there. Or if you lost the screen voltage, or if you lost
that's why you need you need interlocks and I mean, I've done it. I've been through all of it. I still own that 4x15, but that's just stupid. I'll never use that, and I can't get rid of it because it's just too big for people. They don't want it. But yeah, that's why I don't mess with those certain amps. I'm not going to say which ones because when they use those cruddy tubes, they experience arcs between certain elements, and it just blows the crap out of the supplies. But
3x6, according to my cohorts down at Econco, is supposed to high pop between the anode and the...
Hold on, Jim, 1 second. I'm about to run out of time on my camera. Let me delete some of these other videos. 1 second.
Okay.
Okay, we're back. Sorry about that. I'm not a cinematographer, and this is what happens when me and Jim talk. We just talk. So, okay, go ahead, Jim.
Okay, so about the 3x6 tube, it's easy to work with. It's got 42 puff input capacitance like that. It gets in parallel with the input, so that just basically gets absorbed by the C2 cap on the tuned input setup. Output capacitance between the anode and the grounded grid is 24.5 puff. That rises. That increases to around 42 puff, if I remember correctly, once it's inserted into the grid ring, and that's caused by the proximity of the lower fins on the anode to the chassis below it. And then if you got any stray capacitance between the anode and the rear wall, side wall, that all adds up to it. So that's got to be factored in.
Yeah, that's not a problem in an HF amp, but that was something that came into play with the 6-meter amp. We had to scrub.
6-meter amp. We don't have that. It'd be extremely the 6-meter. We could talk about that another time. That's, we got basically zero, extremely narrow wiggle room on that amplifier. This one's a bit.
Yeah.
This one's a bit more forgiving because it's only 160 through 15. So.
Yeah.
This thing's basically dead simple as far as being robust and reliable. Yep. There's not much go wrong here. So
plus, I'm able to fit a lot more. You know, I can fit it all in a smaller cabinet. You know, and there's ample room for the proper components. And why don't you add in, you know, the fact that, you know, these parts are being calculated for continuous duty operation. You know, there's nothing. We didn't guess on a single thing. Every single piece, part, voltage rating, current rating, their placement, everything has been carefully calculated and figured out.
So, when I did the RF deck calcs, I calculated out the current going through the C1 tune cap, how much is going through the coil, how much is going through the C2 cap, peak voltages across the tune cap, peak voltage across the plate block cap assembly, how much current's flowing through the plate block cap assembly, how much is going through all these various tank coil taps. So that's why the switch has to be a lot heavier than what you think it is. Those ratings that Multi-Tech Industries quote are done at 60 hertz. They're not done at RF frequencies.
Well, just like vacuum relays. Vacuum relays, people think it's a 50 amp relay. A lot of people don't understand it's not at the every single frequency that, you know, throughout the.
Okay, on this 3x6, we're using 2 RJ2Bs in parallel on this.
Yeah. Well, we don't have to get in. We can talk about that when we go over it.
We'll talk about that later.
Yeah, when we go.
Neither here nor there. This is just the power supply part. So
but
it's going to be a non-issue. You've got the space on the capacitor. Capacitors you just mounted is that open space is where the blowers.
Yeah, right here. Yeah, see this. I'm going to show them right now. See this? I think I said it before in the first video. So the blower inlet is on this side. Protrudes. The blower side stops right here, and it's hanging, like I said in the other video, and it'll pull air through these vents on the front. The vent will be right here. It's going to pull it in and pass by all the capacitors, suck it in. So the glitch resistors.
On that air intake through that vent, are you going to put some kind of filter on the back side of it?
Yeah, I have filter media and a special.
That might be a good idea because that way ultimately we don't want to end up with dirt and gack getting jammed up in the anode fin.
Yeah, there's a bracket for the filter, and I have a filter here, but I might end up. I'm going to make sure it's not too restrictive. I might end up cutting another hole to allow more air. Maybe, you know, I'll put it in a strategic location where it offers maximum airflow, because that's another thing you always have to factor in your air movement. You want to make sure that components are cooled properly and run, you know, within their max temperature spec. You know, that's another thing you have to factor in. But
okay, just on a closing note, with 125 microfarad filter and the high voltage there, it's not on sideband. It's not going to sag. The dynamic regulation is going to be next to perfect on that. It's not going to sag.
Yeah, well, you know,
in turn with the voltage better regulated, it won't screw up the load line when you're looking at it on a constant current chart, and that aids in linearity like immensely. So,
well, you know what I have to work on, Jim, is my line voltage here. It's just such a. I have like, what do we figure? I was like 260-foot drop. I mean, it's crazy. I have to get that taken care of.
It's loop current. So basically, you've got is an unregulated high voltage power supply. So the brute force method of getting around that is using plenty of capacitance in the filter cap.
Well, I'm still going to get that problem fixed, but when I crank my stereo up, my lights go crazy. But I'll have to show that at some point. But yeah, so that should about cover all this, and I'll have Jim on more, and so I got this done, and like I said, like I've told him, it's like I do this for a living, so I have to really push myself, and there was delay getting back on it because the post office in Canada was on strike.
Yeah, we had a strike there, and things got 15 million packages gone sideways, so I had to do a loop-de-doop and end up resending it a second time. I just one final comment here on these full-wave bridge diodes you're putting in there. Even with key down plate current, you've only got a 50% duty cycle. Most diodes, two legs are conducting, the other two are shut off, and every 8.3 milliseconds the other two conduct. So that's how Peter Dahl rated his
assemblies.
Assemblies. If they were using 6 amp diodes, he'd rate it at 12 amps continuous. So on paper, that's you need some air to be able to pull that off. But basically, the 6 amp diodes or whatever you use for diodes are the duty cycles. 50% duty cycle. The average current through there is not. It's only half, so it's.
Yeah, I'm not sure what I'm going to use for. I'm not sure what I'm going to use for diodes yet. I have some Peter Dahl. I have the square rectangular ones like you have. I have some of those. I have a whole bunch of those assemblies, and I have the long strip ones that he also made, mounted to brackets with 2 fans. I have 3 of those assemblies, and then I have block diodes, boxes of this stuff. So I just whatever will fit, or I'll just make a board. I don't know, but we'll cross that bridge when we get to it. But
that's semantics. That's basically a non-issue. It's just a matter of you got X amount of space and volume, and it's all got to fit. So
yeah, I told him I said in the last video that I would have used an oil cap if it would have fit, but there's just not enough room, and that's another thing. You have to you literally have to play Tetris. You have to plan everything out where everything's going to be placed before you do anything. The RF deck was the hardest. That was would you agree? The output network was, getting all that, the capacitors being mounted vertically, and then getting the all the knobs to line up on the front. I mean, that was just so much work.
Chain drive and inner front panel, outer front panel, and the 3 tank coils split into 3 tank coils with 3 different sizes.
Yeah, that was just a tremendous amount of planning and implementing, and then coming up with new ideas, because there's just nothing, there's a lot of this stuff, there's nothing to really base, to copy, to go by, so it just had to be, just new creative.
The filament choke setup was unique. I thought that was, that came from Tom Ross. That came from WHAI, using those oval type 43 things.
Yeah, that makes it
you can put one on RW90 power cable. You can put 2 of those through there quite easily.
Yeah, that makes it a lot easier. Back in the day, you remember, I still have a bunch of those 43 rods. I think they're 5/8 diameter, but back in the day, I'd wind them with. You used to be able to get number 6 enamel wire. Now it's hard to find. Then I'd use number 8, bifilar, and then parallel them sometimes, 2 chokes to double the ampacity, or even if you had 2 tubes, put the filaments in series. But they're those things are just so much easier. But okay, so let's we could talk all day. Sorry.
Yeah, we'll call that a wrap. That's
okay.
Good enough for one day here.
Well, thank you, Jim, and I'll say, everyone, thank you for watching. And Jim's doing his microwave over there.
I'm eating my coffee up. Tim A's coffee. I wake up here.
Yeah, I'm gonna go back upstairs. I told everyone I'm taking a break today. I'm gonna change the oil in my Jeep. I already did my truck. It's nice out today, but I need to take a break sometimes. There's so much going on with hardbox stuff and amp stuff, yeah. So please, everyone, if you need an amp repaired, feel free to give me a call, and I'd appreciate it if you like the video, hit the like button, and also subscribe and share it. There will be more of these videos to come, and this is going to be a neat amp. And again, at some point, someone wants one, I'll make another. It won't be cheap, but you know, it'll be done right, and it'll be continuous rated. So, is there anything else you want to say, Jim?
No, I think that's it. That's good enough for now, and then we'll proceed accordingly here.
Okay, sounds good. And you know, if anyone has any comments about, I mean, Jim would agree. You know, me, I don't know everything. Maybe Jim knows everything. I don't know, but I think he would say he doesn't know everything. But if someone has an idea or something to say, I'm open to it. You know, that's how we learn, right, Jim? Like, if you have a constructive criticism, share it, you know.
Oh, yeah.
There are a lot of people that are dead, like they're just dead on whatever they've copied or they know, and they don't want to hear anything, and you don't learn, you know. So if you have some idea to share, you might morph it into another idea, you know. It's something even cooler. That's what me and Jim do all the time. We bounce ideas back off, right, Jim? Like we've both come up with neat things.
We give credit where credit's due. My friend Ron, he's still around. He's a lot older than me, and I'm 69. He took that tuned input, monoband adjustable tuned input out of Bill Orr books, which was a monoband thing for either 180 or 160, and they said don't make a multi-band version of it, which he did, because they're concerned about getting it tuned onto the harmonics. So he did a multi-band version. That's where I got the idea from that. So we went to, here's the other problem. I'll just briefly touch on this 3x6 with 500 to 600 watts of drive required. There was no way in heck I was going to do 6 or 9 separate tuned inputs that'll handle 600 watts each. So it's just easier to do a high network with a calf coil and
oh yeah, that was a piece of cake.
And two broadcast variables, and just pad them on the lower bands, and then you can stuff all the power you want through there, and you can always tweak it. And the input SWR is always dead flat. It's a non-issue right there. So
yeah, and the with this one I couldn't fit those 4-section caps in there, so I used two out of an SB220. The older ones were the 2-section one, and then I used a Kenwood TL922 band switch, and then I used the second part of the switch to pad the C1 and the C2 for 80 and 160. It was like the perfect switch to use, and it's rated for, you know, more than it needs to be. So, and the input's 100% duty cycle. So again, every single piece was calculated to at least be able to handle continuous duty and some, you know. And, you know, the output capacitors for the C1 and C2 have no padding whatsoever. You know, it's nice not having any padding on the load or the plate. It's just less is more, because then there's less chance of an issue or whatever, you know. So, but okay, so
okay, that's good.
That's good. So
we'll get into that RF deck later on.
Yep. Okay, so thank you everyone for watching, and Jim, stay on the phone. I'll talk to you after, and everyone have a great day and enjoy your weekend. It is finally Friday. Finally. So, okay. Thanks for watching, everybody. Please like, share, and subscribe.